Okay, so we're going to cover using the JDBC interface with Java to write programs that access a database. If you're not familiar with databases, the basic concept, most commercial databases are called relational database, and I'll talk about what the relation is in that name. But a database stores information in tables, and a table is kind of like an object. This is a table of customers, and each customer has its own characteristics: a last name, first name, address, city, state, and zip code. And so for each customer in the table, you'll have information that identify that particular customer. So we have all this identifying information here, and then we might have, if this is a retail business, we might have invoices that have been used to sell things to the customers. And so we have records of their purchases in the invoices. So we might have a table to store invoices. And again, this would be just like an object, a class called invoice, a class called customer, and each instance in the database table is like an instance of an object. Each row in the database table is like an instance of an object. This invoice has this ID, these number of items, this total price. And so we establish this information. We'll have rows and rows of customers and rows of invoices. And we need to identify the owner of an invoice by a customer. An invoice belongs to a customer when we create it. And so if we just use the normal identifying information here, we would have to include like the last name, first name, address, everything that is in the customer table would have to go into an invoice to say which customer owned the invoice, which is hugely inefficient. It leads to a lot of errors. So we don't want to have to include all this information in our invoice table in order to identify the customer that owns it. So we set up an additional data field here, and we're calling it customer ID. This is the numeric value that represents a customer. And there's a key characteristic of this. In fact, we call it a key, in that this is the only John Smith at 3 Elm Street and the zip code in this customer table. You will never have a duplicate of a key like this. So John Smith's customer ID is 1 to identify him as a customer. And so this uniquely identifies a single customer in the table. You might have another customer ID 2, and so on. So we give them these values because we might have more than one John Smith, right? Maybe at a different address or somewhere. And so in order to avoid putting all this information into the invoice table to identify the customer, now we have this key that we know is unique, represents this John Smith, and so we'll just put it over here into the invoice table, and it identifies the customer that owns it. So this is the idea behind the relational database aspect. The relation is a relationship between these two tables. This is the primary key for a customer, this number that identifies the customer uniquely. Over here, it's the same field, the same data field, but it's called a foreign key because this one doesn't belong to this table. Customer ID belongs to customer because it identifies the customer, but we use it over here as what we call a foreign key to relate these two tables. If we want to say who owns this invoice, give me their name and their address, we don't have to include all that information in the invoice table. We just follow the link, follow the relationship over here to customer ID 1 because we have those matching here. And we say, oh, that's John Smith at 3 Elm Street. Okay. So relational databases have these relationships between tables to help us combine the data in this fashion and not have to duplicate a bunch of stuff in other tables. This one? Well, if this is John Smith at 3 Elm Street, yeah. Oh, the data field? No, you can call it the different names, but I usually use the same name just to prevent confusion. Okay. Yeah, you have some information in each table that tells you this is a relationship between you. Create an identity or a relationship between the two. Okay, so that's the relational aspect of these tables. So we want to look at basically how to create the databases, create the tables, add information to the tables, take advantage of these relationships, delete things from the tables. Those are all interesting for us to do from a Java program. Now, SQL gives us, and this is SQL Server Studio, right? This is the Microsoft product. There's Oracle, there's Informix, there's MySQL. There's a ton of databases out there. Each of them have a different connection to Java, but Java uses the same interface to program to all of them. It doesn't really matter which one you're using. Now we have Management Studio, which is a SQL Server product. This is how we can manipulate our data from this interface, this IDE for SQL Server. And so, for instance, I can create a database here by going into a new database, and then I can create tables under here. And here we've got, actually there's no tables created, they're useful system and file tables, we're not interested in those. But the main point is here that we have the ability to manipulate our data directly with SQL Server from the SQL Server Management Studio, but instead we're going to use Java. And so we can use this to verify the stuff we've done has been programmed correctly. So this is just an interface to Microsoft SQL Server used for SQL development, not for Java development. But we can use this to get a window into what we've just done with Java to see what happened when we do it, to check it and make sure it worked correctly. So SQL is how the language we use to program the databases to access information from them and to manipulate the data. The select statement is the main SQL thing that we use to select data from the tables and show different views of it, show it in different ways, different perspectives. We can select specified fields. We can select all the fields. So for instance, with our customer table, if we wanted to select all the records from the customer table, we would use a select statement, and we'd say select star, which says select all the fields and all the records from the customer table. And the output, and this is running in SQL Management Studio, we would see I added a customer here called Sally Brown. So we have 2 customer records. And these are the customer IDs. Here are the last names, first names, address. So it's kind of like a spreadsheet when it displays it this way. But this select statement is what we used to extract that data from the database, from the table, just from the customer table. So we want to do Java that actually incorporates this statement into the program, but then we also have to communicate with the database while we're doing it. Here's another one that selects all the records from the invoice table. Select star from invoice. And we see I've got 3 invoice records added into that table. 2 go to the same customer, 1 goes to the second, the Sally Brown customer. This is one to, well, no, it is one to many, because we could have multiple invoices could have one owner. Yeah. So I had to think about that for a second. It's been a while since I taught SQL. We use things like join statements. So this is incorporating, this is where I said follow that link to give them the information. So here we joined the customer table and the invoice table. We're saying show me the last name and the first name of the customer for each invoice. And so for each invoice we see it traces that relation back to the customer table and shows us the owner by name of the customer using that customer ID common key. And this is just, again, another SQL selection statement. Right, we got the join here. So select it from customer and invoice. In other words, join the 2 tables on that common key and give us this information from that joined table. Those joined tables. Yeah, this is pretty standard SQL. How do we add new data? Well, here we're adding an invoice. We're adding insert into the invoice table these values. Here's the invoice ID. Here's the number of items. Here's the total price. And here's the customer ID. So we just added a record into that invoice table with those values. And I'm showing the difference here between the table invoices before the insert and after the insert. So it adds that record 4 at the bottom. Yeah, for SQL, I can't remember if it'll work with either one of them, but one way or another, you do have to have it quoted. I think double might work. I'd have to remember. I'm showing it here as double. So, but here the order is important because I'm not specifying the column names. So invoice ID, num items, total, and customer ID. So invoice ID, num items, total, and customer ID here as well. The delete a record is just delete from the table name. Where says find this particular record that has this invoice ID and delete it. So here I'm showing in the table we had record 4 and now we've deleted record 4 with that invoice ID. To create a table. This is how we could create the table from SQL and from Java in the same way. This, we specify the field names, the type. Now these are SQL types. The varchar basically is store up to 6 characters in that field. If you don't need 6, don't store 6. It's a kind of a space-saving data type. Same thing for these. Varchar for zip is 5. And then we have characteristics. This is our primary key, so we specify that. We also say do not allow this to be empty. So all these fields have to have data in them, so they cannot be null. So this will create that customer table in our database. Now that assumes the database is created. We could also do a create database command here and create the database first and then start creating the tables and then start inserting records in our Java program or with SQL here. So those are just the basic forms of SQL, and we're not going to do heavy SQL with the Java stuff we're doing. We're just going to demonstrate how to do it in Java. Then you can expand on it with all the SQL stuff that you need to do. So the mechanics behind all this involve something called JDBC. This is the API for the database with Java. So the API provides a common interface no matter what database you're accessing, whether it's MySQL, Oracle, SQL Server, or another one. If you're using the JDBC API, you don't have to modify your programs for the method calls that are used, the objects that are used. It's a common API for all the databases. Now, where it differentiates is when you get to a different database, you have to have a different driver. And this comes from the database vendor, typically. So SQL Server JDBC comes from Microsoft. You go to the Microsoft site and download it. And it's basically just a jar file that has the driver information in it. Or Oracle, it has its own driver. MySQL has its own driver. And those go to different databases. And this is actually showing you have a program that goes to different vendors for databases in the same program if you want. You just load the different drivers and connect to that particular database. But the programs go through the JDBC API and go through the driver for a particular database and access the database that way. And this is just a bunch of methods and objects that we have available to use in our program. Yeah, don't think DB2. That's old school, right? So the drivers themselves have these objects. They have a connection. This is an object you create to connect to the database, and it basically is in existence for the entire life of the program if you want it to be alive that long. And for each database, we'll have a separate connection. Then we have the queries that we do. So the query is sent to the database, and we get these results back in something called a result set. We'll look at that. So through these connections, through the driver, we get the connections that go to the database and do the queries, get results back. Or if it's just a command to change something, we just send the command to do the manipulation, and we don't get a result set back. Depends on what you're doing with it. So first thing we have to do when we're using the driver is to load it. So there's this method in the class, this is the class name, it's called class. So, and this is a static method called forName. And calling this method will load the driver for your particular database. And it does it by a package name, a class name inside a package. So the package name for the SQL Server driver is com.microsoft.sqlserver.jdbc, and we're loading the SQL Server driver class from that driver, and that will load in all the information that they need for that particular vendor's database. If you got Oracle, it'd have a different package and class name. If you had MySQL, you'd have a different package and class name.
It almost looks like it's a URL package.
Yeah, it does, and that's how you do packages, right? You start with a higher level domain first.
Right.
So this is how we will load the driver for JDBC. And again, here this might be an old link. This might go to 2014. They're up to 2016 now, I believe. But you can get this driver for free, along with SQL Express, and then you can use Java with your database to program it. So the driver manager class gives us all the services for managing the driver, and I mentioned that we get a connection. So the driver manager lets us get a connection from the database, and we do that by using a URL. So the URL is just a string. It looks like a web URL, except instead of HTTP, we've got JDBC:SQL server. That's the protocol. And then it goes for the normal web-looking stuff where we have a host name. Now this is, we talked about localhost the other day, just going to our own system. So I'm using localhost here, and we talked about TCP/IP port numbers, and this is a port number 1433 that we will be looking for SQL Server. So this is kind of a well-known port for SQL Server. And in the industry, you wouldn't be using this port because it is a well-known port, and that's the first one the hackers are going to go for, right? But for this little experiment, this showing how to do this using 1433 is okay. Then you get the database name. So if you have a database out there, it's going to use this name. I'm looking for this. This is my intro Java course. So I call the database ch32. So in my Windows Management Studio here, I'm just going to create that database real quick by doing new databases and give it that name, ch2551, and do no, oops, I missed it. That was wrong. I give it an apostrophe instead of the one. I'm just going to rename it. I've never tried renaming a database. Let's see what happens. Okay, hopefully that won't cause any problems. Inside here, it sets up an empty database. Now it's got some system tables, file tables, stuff that we aren't using, but we'll add some stuff to that with our program. So here's the database. And so here's the database name, and this is all just a concatenated string. So this is the continuation of this string up here for the URL. And we have a semicolon to separate this argument of integrated security.
So that process is Java?
Yeah, that's concatenation.
Okay.
Just concatenating this string with this string into one big URL. It was just too long to fit on one line. Okay. Integrated security goes true. SQL Server gives the option to have either your Windows authentication or separate SQL Server authentication used. The integrated means we're just using the Windows user ID. So basically, if you're logged into your system, you're automatically authenticated. It's going to use your current authentication. It makes it a little easier to get this stuff done. So when you're doing this, because we're going over TCP/IP, even if we're on the same system, we're still going over TCP/IP to get to the SQL Server. We have to use this configuration manager tool to make sure SQL Server is set up correctly. So configuration manager is an applet on our system that SQL Server provides when you download it. Just have to be able to find it. And you bring it up, and you'll see the SQL Server services here. This shows that the SQL Server is running. This is SQL Express. You got it in a running state. All we have to do is we have to go to the network configuration option here. When you click on the network configuration, protocols over here, if you double click, you'll see there's a TCP/IP setting here under the protocol names, and you see that it's enabled on my system. You have to make sure that it's enabled, otherwise you're not going to be able to communicate with SQL Server from your Java program. So configuration manager, go to protocols, SQL Server network configuration, protocols for SQL Express or whatever server it is you're running, and make sure TCP is enabled. Then another thing we have to do is we double click here. We have properties. This is the IP addresses configured for it. What I want to do is go down to the very bottom, and you'll see here that TCP port for IP all, that's all the IP interfaces, is 1433. So that's that 1433 port I was talking about. This is how SQL Server is configured on my system to run using port 1433 with TCP/IP
How do you change the port?
enabled.
Where you change the port?
Well, like I say, in the industry, a lot of times you're not going to use this. You're going to go up here to a dynamic port, and it's going to kind of randomly assign different port numbers. That's the default setting. You have to disable that. You have to blank that out and then put your port number down here to get 1433 enabled.
Okay.
You click OK, OK, After you've done that, you have to come up here, select the service, and you'll have these buttons. You'll have this little circular arrow here. This restarts it. So this will restart it, and it'll pick up those new settings. And this is all covered in the slides here. This is enabling it, right? And TCP/IP, port at the bottom, and then coming up here, and you got to restart it, restart the service. And it'll tell you after you configure it that you got to restart the service. So that's kind of a hint.
Now,
So,
if you're doing it dynamic, though, in the real world, how do you
in the program, there's ways to look it up. There's a browser service. You see here, SQL Server Browser, and that lets you find the port that's being used. Or it might be just statically configured for a certain different numbered port, and then you have to talk to your SQL Server administrators to find out what port you need to use for that. So there's a few ways to do that for dynamic ports. Okay, and that's how you configure SQL Server. Now the driver, there's two files for SQL Server that you need, and both of these are on Blackboard. Under course content, let's see, if I go database programming files, here are the two files here. Okay, one of them is the jar file. That's your driver. One of them is this DLL. This is a dynamic load library that Windows uses. This is for the integrated authentication. So if you're doing that authentication, you need both of these. And for SQL Server, we want to create a project in JGrass, and we'll do this that includes the jar file. So I'll walk you through the steps to do that. It's pretty easy. And then we'll combine it with our source code to run the program. So these are the two other files you need in addition to your own Java executable. And they just go right in the same folder as the Java source code. So for the SQL statement, we use this create statement method, which is provided by the connection object. Remember, the connection gives us the connection to a specific vendor's database using that URL. Once we've connected, we can call create statement that gives us a statement that we'll use for our SQL code. And basically, we can use this for SQL and just reuse it over and over again for different SQL commands. If the SQL statement is a query, we're going to get a result set back with the results of that query. And I'll show you a method that goes through and gets the results from that result set object. So the source code for this, we have, we're importing everything from java.sql star. And we got our class. This customer table ID, this is just a heading for the output table that I'm using, so it's not really part of the SQL itself. Our main method, we have our connection. So we talked about that. That's this URL that has the database name and the port number and integrated security. That's what we're going to use to connect. The objects we're going to be using are a connection, a statement, and a result set. This is more header information here, the results, so you can ignore that for now. So this all goes in a big try, or a big try with resources. Now, this is older code. In the try, because a lot of stuff can go wrong when you're doing this, you need to catch the exceptions. We do that class.forName method with the driver name using the package and the class name we're loading for SQL Server. So now we've set up the driver, and now we can connect. So we get the connection. This is a connection object, con equals driver manager.get connection, and we pass that URL that we just created. This will give us an active connection to the database where we can do our programming with. So after we've got the connection, I start creating a bunch of SQL statements. These are all just strings. If you look closely at them, though, they have the specific formatting for the operation that we're doing. Here's the create, and I just concatenate a bunch of stuff on there. And I make sure, in this case, all the arguments go inside parentheses, so I have to make sure I get the parentheses inside the string, and they have to be terminated by semicolons, so I get that inside the string. And this string terminates just the string concatenation operations here. This is our create table command in SQL. This is our drop table, which says delete the table. I'm done with it. Here we're adding the data for two customers, John Smith and Sally Brown. Here's our regular query statement. Select star from customer. Okay. So we've got all these commands that we're going to execute. To create them, we have to use a statement object. And so here, statement equals com.create statement. We got a connection up here. So down here, we're using that connection to get a statement that will be reused for the SQL commands going to the database. So the first thing we do is this method called execute update. So execute update modifies the database. And so we're calling it here. Now I've actually designed a little helper method that's also called execute update. So this is actually calling the statements execute update, but I'm passing the statement here to the helper method instead. So we'll take a look at that. But this is going to modify the database. And I'm passing the create customer table command. So this is going to execute that command. And I show the results of that. Hey, I created this table. Once we create the table, I execute update with the insert commands to add the customer data to the customer table. Customer 1, customer 2. Again, I'm passing that statement. I'm reusing the statements. This is the command I'm executing here. So if I go down and look at this execute update method that I've written, the reason I wrote a separate method for this is because to do the update statements, you have to do a try-catch in those also. So instead of having this big nested try-catch situation, I just wrote a separate method to include the try-catch for the execute update method as a separate method here. So execute update, I pass a statement, I pass a string in, and in the try, I use the statement to execute the update command. So execute update, this is the SQL I'm passing to it. And if nothing bad happens, that's it. That's all it does. It executes that update, modifies the table, or modifies the database. So this is a void. It doesn't return anything. If something bad happens, we'll get the stack trace and we'll see what happened when we try to do it. Now I want to do a query. Now because I don't need this in a separate try-catch, I did not write a helper method for it. So I just use, so right here, remember I called the statement.executeUpdate. Here I'm calling statement.executeQuery. I pass the query. Now the query returns something. It returns a result set object. And that's what this rs variable is. Rs equals statement.executeQuery with the get customer query, which is select star from customer. It's a very simple query. Now I've got a helper method to show the results because you have to do a little work here. So I pass the results statement of the result set object and some constants for the results to show them in the table for the output. So if you look at show results here, where does it start? Here. Passing the result set, the title of the table or the data, and the identifier of the table. This is so that I can pass different result sets in with different queries. I'm just doing one now, so I'm not really varying that, so that's not really needed here. But I print the title of the data, and so for the result set, I'm just doing a while loop and calling the iterator for the next row of data. So it iterates through each record that returned in the result set. So I get the first row, which is our John Smith customer. I'm making sure, this is kind of like you're doing an instance of, making sure it's the right table that I'm working with. And I use the name of the field to get the data in that field for that record. So I pass the customer ID to the get string. Everything comes back as a string. Get string, customer ID from the result set, and I set that string here. Last name, first name, address. So this gets the first record, the data from the first record, using the data field names as the key values to select it. And then I just do a big formatted print with that data. I'm going to print customer ID, last name, first name, address, and so on. So I'm looping. So now I'm on the Sally Brown customer. And again, I do the same thing. This will get me the next record in the database, each field value. And I print those values here in a format. So this is just looping through the result set, getting each record, extracting the data associated with each data field, and then printing out the information. So actually it's pretty simple, but it is a little bit more work to do that. So this is the show results method that I'm calling here. So I've created the table, inserted 2 customers, I queried the table for those 2 customers, and now I'm done with the table, so I'm going to delete it. So I execute update again with the drop customer table command. and it drops the table. If it works correctly, and it deletes the table. And that's all it does. Now notice here we have a bunch of checks in the finally after the catch, which is just a generic exception here. In the finally, I'm checking to make sure if any of this stuff still exists, it needs to be closed. I make sure it's not null first, and then I close it. If we did try with resources, at least some of these I'm sure are auto-closable, and we wouldn't have to do this. But because we're using the old style try, we're doing this explicitly. And that's all it does, really. So if you look at here, this is a result of creating it. It creates the table, or running customer table created, queries the information, and then it drops the table with all that stuff that's going on underneath. So to get this to run, after I've got SQL Server configured, make sure it's running, I've got the database created, ch32. So what I do is I go to JGrasp, and I need to download these files. So I'm going to download the jar file, save link as, I'm going to put this on in my itech folder, which is itech Java here. Save this. I'm going to download the SQL auth. Save link as. Same folder. Oh no, this one, that's not right. Try it again. Save link as. There it is, the DLL. So I'm going to save those two files. And this is the code. So I'm just going to copy and paste this into JGrasp. But I'm going to do it with a project. So I'm going to bring up JGrasp. And what I want to do is I want to open a new project. So I go to project and new because I need to pull that jar file in also. So new project. I'm just going to call it JDBC. Now I'm going to create a new directory. I want to keep everything in this folder where it is. So I'm not creating a new directory. And I go next. And it gives me the options to add the files. So I'm going to add the files to the project. Create. Oh, but I didn't do the Java file yet, did I? Oops. Okay. Well, I'm going to go ahead and add the jar file first. So I'm going to go to all files, find my jar file. JDBC. It was called right here, jar file. I don't need to add the DLL. That just needs to be in the folder. I'm going to add the jar file though. Okay, so now down here, I'm just supposed to say done, and then I got to create the Java file still. So down here in my project, I've got my JDBC project with that jar file. So I'm going to go here real quick and do file, new, paste my Java code in, save that. Now I'm going to add that file to my project, close it out and add it. So add files and JDBC.
file?
No, the source file. So it's called cop2551db.java. And that's all I need. So I've got my database, my .java file, and then my jar file for the driver in the same project. So now I go to project, and well, in the project bar here, I've got the build tools. So I'm going to go ahead and build this. And you see here it built. And then I just run it. And table created, there's the data, it dropped the table. Now over here, I'm not going to see anything interesting because I'm dropping the table, right? If I go to view and refresh tables, there's nothing interesting there. So what I'm going to do here is I'm going to do a little continuation thing. Go back to my project, open up that cop2551. So here, I'm going to scroll down, here's where I dropped the table. So I'm going to do a prompt. System.out.print. Enter any key to continue. And I'm going to do, I need a scanner. Import java.util.scanner. So create a scanner here. Scanner in equals imp equals new system.in. Okay, so nothing new there. Just create it. And so I'm going to do an inputs. INP.next line. Don't need to save it. I just need to get the key here and continue. So I'm going to pause it here. That way, before I draw the table, I can go look in Management Studio and see what I just did. So if I run it again, after I build it. Okay, we go through. So customer table created. Here's the customer data, and now it's waiting for me to hit something. So I'm going to come over here, and I'm going to refresh my view again. Now under tables, here is the customer table. This is Management Studio, right? And under the Management Studio, or under customer, if I right click, I can do show or select top 1,000 rows. And here's my data here. So this is Management Studio showing that that database is active. I created the table, inserted the customer data, and here's the data. So now if I hit a key over here to continue, it drops the table. And now if I refresh, let me collapse these and collapse the tables and refresh. And the customer table's gone, so it got dropped. So basically I just cleaned up after myself. So this is showing how we can do the SQL commands with a Java program. We load the driver, create a connection, connect to the database, create a statement, which is just a container for all of our SQL statements. Then we start loading that statement with our SQL. And so we just call the execute update method for executing modification commands, or execute query to execute a query. Execute query returns a result set, which we have to parse to get the information from record by record. Execute update just executes the command and throws an exception if something goes wrong. So it's really pretty simple. And you can take this and do the joins and do all the other operations you do from SQL, and do it from a database program. And they got a few examples in the book. They show a couple different things. They use this positional parameter method where they kind of make it a little more dynamic for their SQL. So this is kind of a direct way to do it, but it still works. And you can use this on your own, create your own data, and play around with it and get used to it. So that's really all there is to it. This little summary slide just shows we have the connection object, and we have the statement, and we have the result set. And the result set contains all the records of the query that we ran, which could be empty, depends on the query you run. Statement is general purpose for both queries and for modification type commands. The connection kind of controls everything for the connection to the particular database. And that's it. Want to take a look at anything else? Any questions? So there's no programming per se assignment for this because it is so particular and you have to have the software and everything. But again, if you want to try it, go for it. Use these slides and go through it on your own and see how it works.